start the recording. Watch my CPU just absolutely demolish itself. And hope that audio is still doing well. Okay, so what's the goal for today? So the goal for today is mostly to try and clean up what we have here. So this is where we started at the end of the last video. Last video had some issues, ended up recording in very low resolution. It's streaming slightly better now. So I guess here's what we're gonna do. So plan is to kind of clean this up. I went through and checked out all of these parts in a spreadsheet, and let me actually just check out what that spreadsheet said right now. I just want to see how far under the weight limit we are exactly right now. So if you missed last stream, this is a robot design that is, the goal is to basically build a sort of 30-pound sportsman robot, which means that it's not going to be going up against any like crazy powerful spinners or anything, which I felt like I didn't want to spend a ton of money on replacement parts, so this felt like a pretty good way to make an affordable 30-pounder. So the goal for today is to kind of do some of the major things that I had kind of planned out when I had, so I'd made a spreadsheet. I can't put it up right now, but basically the robot is about 3,600 grams under the weight limit. But that's without batteries and all sorts of other electronics and stuff. So what we need to do is we need to try and trim out some of the fat. And in order to do that, what I've figured out is we can actually get rid of this entire midsection. All these standoffs, these two middle bulkheads, mid-rails, because this is already a pretty bad mounting solution, right? So what I was thinking is we use pillow block bearings on the outside, which would kind of support this entire section here. And what I'm thinking now is just get rid of this entire middle section. Get rid of all 6 of these standoffs, get rid of all the screws, get rid of these 2 middle bulkheads, each of which weighs about, I think it's about a pound. Let me double check. Weapon mid-rails are about 323 grams a piece, which is about 100 grams lighter than a pound. So that's pretty significant weight. So what we need to do is, of course, just go and fix this. We need to get rid of these. So let's actually just find these. Okay, where are they? Completely get rid of those. Completely get rid of all these standoffs. And that saves us about, let's figure out how much weight that saves. I have a hunch that I forgot to put this stream public. Manage. Yeah. Yep. Stream is private. We need to change it to public. Well. There we go. There have been some stream teething issues, but okay, changing audio levels and stuff. Turns out I accidentally set the stream to private, but okay, everything is working. I guess let's just let's fix this. Okay, so I guess let's just start this again. Well, actually, now we don't really need to. Basically, I forgot to set the stream as public because I still really suck at this, but I'm getting better. So, anyways, what we're trying to do here is basically remove all the unnecessary stuff from this robot. So what we ended up basically having was a lot of extra weight in the middle, and we need to get rid of that. So it's like the stream's healthy and stuff, so we just gotta, yeah. Okay, so I have a list of things that we need to do. We need to model the pillow bearings. So basically, the idea is to completely get rid of this whole setup, which we had this big convoluted setup here where we had these two middle rails, which would have pillow bearings on the outside, and these would be standoff to the outside, like to the side rails. But that was very, like, why we could just further support these with like some maybe corner braces or something, and then just have pillow bearings here, and we'd save, it ends up being about 2 pounds, or about 1.5 pounds from the two mid rails. And then if I look at the standoffs, where are the standoffs? The standoffs save an extra 186 grams, which is actually pretty significant. So what we need to do is we just can get rid of this. And I ended up finding some pillow bearings. I don't have them on this computer. I'm using a super convoluted setup to actually stream this thing, but we're getting there. So they're 8mm bore pillow block bearings. So looks like they are roughly 55. Oh yeah, so that's what we're gonna do for this. We're gonna be streaming this. Okay, let's just get into it. Let's start a new sketch. Okay, so it says it's about 55mm wide, which actually isn't that much. We're going with an 8mm bore pillow block bearing, which has basically shaft collars built into the bearing, so we don't have to worry about the axle moving or anything. Haven't quite decided whether I'm going to downsize the bearing to the smaller size yet, or downsize the shaft to 8mm, or if I'm just going to like trim down the sides. But that's where we're at right now. So just reorganize this a little bit. Okay. And it looks like it is 13mm wide. This is actually a surprisingly like sort of small ball bearing, but I guess if it works, I don't know. Okay, it says that it is 5mm thick. What is up, Shelton? Welcome to the stream, man. Hello, Ty. Okay, so there's the center. It says it's 42, which means that we go 21 off to each side, and this is where the mounting holes are. Oh, that's right, the SpaceX launch is going on. says that it is. It's 4.5. It's 4.5. So here are the mounting holes. Looks like the corners are trimmed off, so I'll actually be filleting the edge. So, but let's get these holes going first. What is up, Samuel and Nicholas and Miguel and Brandon? I'm doing pretty well. I'm tired, but feeling pretty good. Finally getting to work on this project again. It's been a while. I've been distracted with papers and all sorts of other stuff that's not exactly what I would like to be doing, but oh well. Okay, so now then it seems like we've got 28.5 millimeters from the bottom is how tall this thing is. So we got that. Looks like we've got a circle. I can't exactly tell how wide the circle is, but the data sheet spec image is really small. It kind of sucks, actually. Looks like the circle is 15 centimeters. It doesn't sound right. No, it's just 28.5. Just actually do it here. Okay, so that is that, and then we have to do another hole with 8 centimeters in the center. We can extrude this at 13 centimeters. Okay, nope, we need to extrude it at negative 13 centimeters. There we go. Okay, that's actually looking pretty nice. Then it looks like off of one side there's I can't quite actually tell what that is. Shoot, it looks like we actually need to create a sketch. There we go. There we go. That looks much better, actually. It's not perfect, but it's gonna be good enough for right now. So, what do we gotta do now? We got to I guess let's just make a center thing. It looks like it goes about, this data sheet is actually really bad. I guess we're just gonna create a circle at the center. Looks like it's maybe 13. No, it's definitely like 12. Okay, and then we extrude this. Oh, extrude this. It looks like it's maybe like 6 centimeters. Kind of just eyeballing it. No, 6 is way too much. It's maybe, or 6 millimeters. Dang, centimeters would be 4 centimeters. Millimeters. Dang it, dude. Dang. There it is. Then inside of here, I'm not modeling it because this is enough to kind of get the gist down. There would be, it looks like 2 or 3 set screws. Let's save this as pillow bearing, a millimeter shaft. Okay. So now then, I can get rid of that, go back into here. Okay. So now it looks like we've got to, let's actually just get rid of the fork and the weapon axle, because we also really don't need bodies, any of these bodies, because we're completely reworking the aesthetic of the bot. I've done some sketches, which we'll probably go into the eventual video for this, but the idea is to basically kind of give it that very 90s consumer electronics feel, rather than the like faux 50s sort of thing that we were for some reason going for last time. That actually was like really ugly. I don't know why I thought that would be a good idea, but we're completely getting rid of that design. We're gonna go with something that's a lot more reminiscent of like a Sega Dreamcast or like the original Xbox kind of, with that whole thing. I just can't get away from video games, can I? But yeah, so I guess the major things we have left to do are we have to figure out how to mount the forks. We have to figure out which size sprocket we're going to go with. We have to design the top and bottom plates. We're also switching out of these wheels, which I guess I'll just put those on. We can put those on pretty soon too. We've got to figure out how to retain the motors, because if we actually look at how the motors are held on, they're not right now. So I need to do some research on how people retain these drill motors, because I don't have access to any crazy CNC stuff, right? So I can really only do like simple CNC stuff, which is why these are mostly just like circles. The plan is to kind of just absolutely use the 3D printer to do basically everything that I can't like machine myself, which shouldn't actually be that big of a deal. I think Maker's Muse, the 3D printing channel, had a video where he actually showed off using 3D printed gears in a 30 pounder, and they held up remarkably well. The lathe I'm using had a bunch of broken gears when we got it, so we're using plastic gears on the lathe, and it's actually working pretty well. Like if you do 100% infill, you can get away with a lot. So that's kind of the plan, is to do that. But let's get the a lot of people do 3D prints. Yeah, I just don't know how viable they are in 30 pounders. I know most people like do a lot of CNC stuff. If you're interested in reading more about 30 pounders, I highly recommend checking out like Robert Cowan's videos. Those have been really helpful in kind of trying to parse this thing together. But yeah, there's a lot of really good like blogs and stuff. Let's insert that into the current design. Wait for it to load. Nylon gears? Ah, yeah, I guess. Oh my, this is actually really, really tiny. Let's move that out of the way. Okay, that looks good. A lot of people, okay. Yeah. It's kind of what I'm thinking. Trying to decide whether or not I want to do nylon or oh, I need to actually, come on. We're just gonna eyeball this. It doesn't need to be perfect. It's just the CAD. It's mostly for figuring stuff out. Ooh, you're working on a 30-pound Byte Force like bot? Are we talking new Byte Force or old Byte Force? Cause I know there's 30 Hall Uberclocker, which is like old Byte Force by the guy who built Overhaul, which that's a bot that I would love to fight actually. Miguel, thank you for your kind comment. I love making the Vex stuff. I'm glad people are using it to learn, because that's why I make them. Because I kind of had to figure it all out on my own and through a lot of different places on the internet, and I kind of just wanted to, you know, make something that was a lot, kind of would hold all that stuff like into one thing. Vertical spinner, yeah. The vertical spinners are one of those like designs where it's like almost everybody has one that like, or not almost everybody has one, but there are a lot of them. Combat robotics group called Pandemic. Okay, I might have seen that. I'm not actually sure. I haven't been really paying too much attention to stuff. I need to get that wheel back on. It just doesn't look right with only 3 wheels. There it is. We're also switching out the wheels. You know, we might as well actually just do that. Nope, not the nut strip. We might as well actually just do that right now. We're going to switch over to these T81P wheels, which are also by Banebots. They're not compliant like the other wheels are, but they're slightly bigger, as you can see, which will give us a little bit more clearance room for the 3D printed top, which, yeah, we're going to go with 3D printed top because I want to do some pretty crazy geometry on the top, and that's going to be a nightmare to make with anything but a 3D printer. But should actually be pretty nice. Plan is to, if I'm fighting a hammer bot, put a sheet of titanium under one side, or on one side, because it's, if I'm fighting like another lifter, like it's not going to matter. And for this bot, it's kind of a lot of aesthetics. Like that's kind of the thing that I'm really caring about in this robot. I want to make something that is fun to drive, relatively affordable to make, which is why I'm using drill motors, and hopefully won't get obliterated, which is why it's got crazy thick like side panels and everything. So we're gonna do both of those. Okay, we're gonna need to move this out actually. We might want to double up the wheels. Haven't quite decided about that yet. But the wheels are actually pretty light. Let me check my spreadsheet and see how much they weigh. Where are the wheels? 145 grams a piece. Which isn't that bad actually, which means that all the wheels weigh just over a pound, so a little over like 1/30th of the robot, which actually isn't that bad. Okay. And then even though this is sort of, even though the back extends a little bit farther past it than I'd prefer, I think we're going to redesign this back plate. It is both incredibly heavy, weighing over a pound, I think. What's the back rail? Over 2 pounds. The back rail weighs over 2 pounds. Wrong mouse. I'm using 2 computers to stream this, so. This back rail right here weighs over 2 pounds. Actually closer to 3 pounds, like 2.5 pounds. Which is insane. So we have a couple options. We can either make it thinner, we can pocket it out, or we could actually try and, like we're kind of doing with Blast Wave, just use the heck out of 3D printing. Maybe go with a thin aluminum rail, almost like this thickness, and then back it with 3D prints, because I want it to have a very like aesthetic design. Oh boy. So that's what we got right there. Let's change the, where's the weapon axle? Okay, so the weapon axle is actually, we might want to find something that's a little bit bigger than or a little bit bigger than these bearings, but we're going to use it for right now. It also looks like it's close enough that I'm not super worried about it. Like this would be okay. I wish it would be a little bit longer, but I can source that, and I'm not super worried about it. Where's the webbing axle? There we go. Move copy. So then, yeah, I think we're gonna want to get a much bigger bearings, which are gonna weigh a lot more. But I guess we could custom make some pillow block bearings, which isn't out of the question, actually. Yeah, those seemed really small. I don't know why I thought that 8mm would be okay. Maybe I was looking at the radius of this when I was looking at it. Yeah, that's what was happening. I accidentally looked at the radius. Could I just bolt plastic to the back plate and make it thinner? That's kind of what I'm thinking. Yeah. That's kind of where we're at right now. But even like titanium like is ridiculously heavy, so I'm thinking maybe like, I think this is 1/2 inch. Let's actually double check that. Is this 1/2 inch? Yeah, 12.7mm is 1/2 inch. So if we do 1/2 inch, if we maybe pull it down to 1/4 inch of aluminum, that should, yeah, that would reduce the weight by half, which would mean that it's just over 1 pound. And then some low infill PLA on the back, which would also help, well, with the design that I'm thinking would help prevent it from like tipping onto the back. We don't have to worry about it tipping onto the front because we have the forks out in front, which actually, let's get those out. Let's move these. Okay, we went a little bit far, it looks like. We're gonna redesign the forks too, because not entirely liking how they're looking. I kind of want to have some hooks on it, but I haven't quite figured out how I want to do that with this very symmetrical design, because I don't know, haven't quite figured it out yet. Although this design should have these kind of like running straight along the floor, but we'll figure that out. We also might want to pocket this out a bit more. We have one pocket to let wires go in and out, but this in itself is, I think it's over 1 pound. There's the mid rail. Mid-rail, 455, which is almost exactly 1 pound, unless I'm messing up the stuff, but... So, I haven't quite figured out how I'm going to fasten everything to this axle. I don't entirely feel confident enough in my lathing skills to do a keyway. Or even, like, if that's the best way to make a keyway. So I could easily do a keyway, right, with, like, some hacky drill bits and stuff, but the question is more like, how do I make a key, right? I guess I could do 2 keyways and then sort of like a notch or like a thing to fill the gap, but I'm almost thinking that a flat with some really, really big set screws might be the best option. Haven't quite decided yet, so we'll figure that out eventually. What was I gonna do? Oh yeah, we got 2. I have sprockets in here somewhere. 16 tooth. I think these are from Vex. I actually don't know. I looked all over to find. I looked all over to find the right size sprockets for these shafts. And we're actually going to be replacing the official shaft from... Well, not... Okay. We're going to be replacing the stock shaft from BaneBots, because you can see that this has a hexagon-shaped hole in it. And what we need to do is basically swap out this shaft with another one that BaneBot sells, so it's not exactly like we're going full-on aftermarket with it, but still going to require disassembly and everything, but shouldn't be too big of a deal. Let's see how the 22-tooth one works. This will let us get a bit more mechanical advantage. We might actually want to see if we can get bigger sprockets. I kind of wasn't really thinking about the correct size, but also that's going to cause problems with the shaft diameter. I guess we could just see if we could find sprockets that have the same like pitch and stuff. But yeah, we're gonna have to. Let me actually make a note for myself. Where's sprocket? Figure out what. So we gotta find a sprocket that works with the correct like axle diameter. So that's our current problem, but it's actually not looking too bad. We might want to put some standoffs or something between these, just because that could help kind of keep them on the same angle, as it were, so we don't have one going up and the other one going down. Also kind of to protect the sprocket, because I don't really know how to mount anything up here. Yeah. But as of right now, like, this is looking pretty decent. Oh yeah, that's right. So what I'm thinking we're going to do is we're actually going to end up using nut strip for these front and rear sections too. We'll just copy these. Which, dang, that worked almost perfectly. There was a reason for this. I actually need to like remember what it was, but it will save us from tapping holes directly into the pieces, and we just drill through into the nut strip. Why not use belt instead of chain? I don't actually have a ton of, like, so this is a lifter, right? This is a 30-pound lifter. So I don't have faith that the belt is gonna not slip, right? And I'd feel better if it was chain, because, you know, belts slip. That's kind of the whole thing with belts. And I don't necessarily trust that it's gonna be able to hold a 30-pound robot up, at least even partially, without slipping. And if you can get the tension big enough that it won't slip, it'd probably be difficult. Like, it'd probably be difficult for the motor to move. I guess I'm not accounting for timing pulleys and timing belts, but I don't know. I haven't really worked with chain, and this also seems... Shoot, I accidentally just moved these and didn't copy them. Whoops. Yeah, but I don't entirely have a ton of confidence in belts. They work well for things like weapon bars and stuff. Like, I think they were really good for Blast Wave, but I don't entirely know if I trust it to do 30 pounds and lift that. Oh, we do have motor hubs, but we got to figure out exactly how we want to mount them to the drill motors. Okay, so we actually have a couple more things we need to model. We need to model the batteries, which I wrote down the size of those in my notebook. So we're just gonna be modeling these as rectangles. So what we gotta do is we gotta make a rectangle that is 143 by 51. By 23. Okay. So that is the battery. It is a 500 milliamp hour battery. Probably Turnigy because, I don't know. It's been a while since I've actually been able to work on this project, so I'm trying to kind of go off memory. I think I bookmarked it somewhere though. Okay, and then here are the ESCs we're using. The plan is to use quick run ESCs. I think they're for RC cars, but they're incredibly cheap because I don't feel like so the goal with this robot originally was to spend less than was it less than, I think it was less than $300. And well, I would love to use like a Rage Bridge or something. The Rage Bridge is like $200. Timing belts. Hello Noah. Hello Joshua. Hello from Israel, Eric. Hey. Your experience timing belts could support a lot of weight and not slip. I mean, yeah, I haven't exactly done a lot with timing belts. I just kind of went with chain because I assumed that that would be a little bit stronger. I was less worried about, like, I don't know. That's just kind of what came to mind, and we'll at least go with it, we'll at least go with it because I know that I can find sprockets that fit onto the shafts and won't have to custom make anything. But let's see with this quick run. It's 36.5 by 32. And then it's 18. Okay, so here is our ESC. It is just a tiny brick. We're not modeling wires or anything, but that is fine. Let's get rid of that. Save this in case my computer decides to just crash. Okay. So we've got two quick run ESCs, which are these guys. Currently thinking ESCs in front and then battery in the back. But I don't quite know. There's actually the possibility that we could stack the battery underneath the motor here, which would give it some extra protection in the case of like a hammer bot, because then we'd have to get flipped over and then they'd have to like go at it from the effectively underside to actually like puncture the battery. Let's see how that works. Excuse me? I don't know how I screwed that up that badly.
It's the new style.
Okay, we need to fix this. Nope, don't ground that. Wait, no, we don't need to do that. We need to do this. Okay. Oh, come on. You know what? I'm actually I'm actually really liking that battery placement. Then we could tuck the other two quick run ESCs like against this wall. Could tuck one against that wall. Then we'd have to copy it. Don't forget to create the copy. Stack the other one against that wall. And then, yeah, we're gonna have to cut another hole in here on this side. I think that's probably the best option, because then we can easily run wires across. We also have to figure out power switch. Do we want to use like a FingerTech switch, because they can be used. It's from what I've read on their website. It sounds like the bigger issue with that is more so wire thickness, the gauge of your wire, rather than the absolute like size of the switch. Yo, what's up, Ryan? Welcome to the stream. But haven't quite figured that out. There's also the Waiachi switches, which are way bigger and also way more expensive. I think it's like $8 US to, is it like $40 US or something? They're also way bigger. There is also the possibility of just using a link. I haven't done that yet. And from all the memes, I'm not quite sure if I want to. But yeah. I also have to decide whether I actually want to use nut strip here. I don't know why I said that I wanted to use nut strip in my document. Yeah, I haven't quite figured out what I want to do there yet. Because I could very easily just tap into these, right? Like tap holes in these side rails and just screw in from over here, which is a valid option. Then I could actually have a system where it just kind of pulls out, where the cosmetic, where I almost have like a pull-out system, like friction fit or a couple small screws to put the back on. Because I shouldn't actually need to mount anything to the back, and that would allow me to have a lot more consistent aesthetic touches. Yeah, and then I could then I could have a system where it sort of like pins into the corners with the 3D print. So the 3D print sits in and almost like just sort of latches into these corners, and you have a couple of small screws up in the center that screw it and attach it from the center. But that seems like it seems like it might be a bad option. Joshua, I'm using Fusion 360 because it is free for hobbyist use and also students, both of which I am. So it works pretty well for my use case. So yeah, the question is, what do we work on now? Should we just go for the lids? Cause everything here, I need to figure out what actual pillow block bearings I can get my hands on. I need to figure out what sprocket I'm using. We could go for a fork redesign. But, you know what, yeah, let's go for a fork redesign, but let's just base it off of the old fork because I don't feel like, yeah, let's just Let's just build it into the old fork, because then it'll just automatically jump in. We don't have to worry about anything. So I kind of want like, I kind of want it to like almost like stick out. Let's just get a cord running through it so we don't have to like worry about that or anything. There's the midpoint. Not the center of mass, but like the straight up midpoint. There's the midpoint of that, which we could actually... how far did I go in here? Let's just change it to 6. That actually does nothing. Oh, here's what we can do. Why is... That's not the midpoint. Okay. See, this is where stuff gets difficult. And this is also going to be really, really difficult to make. Because, I mean, it doesn't look too bad, though. That also has a pretty good chance of, like, just coming off. You know what? I think we're just going to leave the fork as it is. We're not going to touch it. Don't save. So, I'm pretty happy with how it is right now. So let's actually just try and jump onto the... let's at least just get a start on the lid. Let's get like a base going, and we can start like sort of trimming from there. Well, actually, we need to measure this first. $266.528 millimeters. Oh boy. Okay, so that is the height. Nope. Okay, we don't need that anymore. We can get rid of that. And we'll inspect and figure out the width. Nope. I'm doing it all wrong. 394 millimeters. I'm gonna try. I think we're gonna just kind of try and overshoot it a little bit, because worst case scenario, I can always like trim a tiny bit off the corners, or it'll overhang a tiny bit onto the. You know, we're gonna change this to 267. Come on. Okay, so we got this. Here's our base. So now the question is, how exactly do I want to go about making this? So there are a few options that I could pretty easily like actually do. So there are a few like ways that I could go about doing this. I could go with a whole bunch of different planes and then sort of extrude them into the nope. Let's just create sketch here. Okay, so we're gonna go with 15 millimeters. That's how thick we're gonna go with this. Nope. What? Nope. Okay, so this is our canvas to work with. I have some sketches of this that I made, but I do not have them on my computer yet. Okay. Now I gotta figure out exactly how I'm going to make this happen. Okay. So, we first got to... Let's first... So what I want it to do is I want it to have like a circle, like straight in the center. So just chuck a line in there. The question is, how big do I want the circle to be? Kind of like 200. Gives me just a little bit of room there. Yeah, I'm kind of liking that. That might be too big. You know what? No, I do like that. So then let's actually just like really quick frame out what I'm thinking just with lines, and hopefully the perspective sort of makes sense. Yeah, that's really what I'm thinking. And that would go there. And that would go there. And so these things are sort of like sloping down, and then these are sort of sloping down, and this is like almost nothing, like right here on the side. So that's kind of where we're at right now. But I gotta figure out exactly how I want to do this. Because... Nope. We'll finish the sketch because that'll give us a pretty good basis of what we actually want to do. Create form. Edit form. I've actually used the form tools before. Okay. No, I don't think this is what we want. Box, cylinder, quad ball, symmetry. Create. 2 or more sketch profiles or planar faces. I don't think form is actually what I want. So the question is how... Okay, there we go. Now we're out of it. I think we're just going to have to do this with offset planes. There's almost certainly a better way to do this. But I don't have that knowledge. No, we don't need offset. Plane at an angle. Plane through 3 points. There we go. Okay, so we do that point, we do that point, and we do that point. Okay. So that actually looks pretty good. So now then we're going to have to do a sketch. Create sketch. and none of this geometry actually like counts. So okay. Wait. No. So we gotta do is we gotta do okay, this is going to be difficult. Okay. So now then, I'm running out of battery. Crisis averted. Nope, crisis not averted. The power cord is tangled with my headphone cable. Crisis re-averted. There we go, we're fine. Okay, so it's not perfectly in the center. Oh wait, so here's what I can do. There's an option for circle. Specify 2 points on the diameter of the circle. And that is not what I wanted. This is a real puzzler. Can I... You know what? We could do a 3-point circle. That point, that point. Oh yeah, that's right. It's never going to actually... Okay, never mind. I stand corrected. Okay. That's as close as it's going to get. Yeah, so we had to be looking straight up and down. Okay. Okay, so here's what we're going to do. We're going to finish this sketch. We're going to go to the top. Select all these things and make sure that that face... Nope. Okay. So we're going to do sketches. We're going to sketch 3. We're going to not rename that. Okay. Okay. Do that. Select underneath it. And then we're just gonna like destroy this entire like thing. So we're gonna solid. That didn't work. shoot. Not that. There we go. This is just me fighting with Fusion. Negative 14.5. There we go. We still got a tiny bit of that. Can extrude this. Nope. Join. Oh, heck yeah. Heck yeah. Okay, that's like exactly what I wanted. Now I've just got to do that 4 more times. Four more times? Yeah. Face down from top. What I'm gonna end up having to do is okay, so we know it works. We're actually just gonna bring everything back to the way it was. We're gonna end up just creating another plane through 3 points. Pick that point, and that point. We got this plane. Then we'll just go to top, create a line from this point. Are we on this sketch? Nope, we're not on the right plane. Create a sketch. Ooh. Ah, man. Just checked to see if SpaceX was launching because I got an alert on my phone, and actually they ended up having to push it back, which kind of sad, but I guess it's people, so it's a pretty good idea. So I feel like I'm doing this the hard way, but I don't know any easier way to do this. So going to the line right here. Okay. Okay. And then what we're going to do is we're going to do circle. No, not 3 tangent, 3-point circle. Boom. Boom. And then we gotta find another point on the circle, which I guess I can actually just approximate it because if it's slightly off. Okay. So now then we got that. So we'll finish the sketch. And now we have 2 weird circle things in the middle. We gotta do that 2 more times, and then we got to figure out exactly what we're going to do for these things, which should also have their own individual things. So by the end of it, we're going to have 1, 2, 3, 4, 8, 12 different faces and frames and everything. But my throat is starting to really hate me for talking this much, so I am going to stop streaming for today. We should really save this as lid cosmetic. Cosmetic lid would have been better, but we're past that at this point. Thank you all for watching. Thanks for coming and hanging out. It was really fun streaming. Yeah. I don't know. I don't think I'm gonna keep the VOD up here. Current plan is to make a second channel, but I haven't quite finished that yet. So second channel for like these VODs and stuff. So go check that out. It'll probably be public pretty soon. Anyways, thank you all so much for watching, and have a great day. Enjoy your weekend, enjoy your summer, and we'll try streaming some other time soon. Goodbye.